All right, once again, we will just go through a bunch of problems today that involve logarithms. The key idea to continue to remember as you go through these is being able to take it from a logarithmic form. You have log base b of some value is equal to an exponent, can be transferred into the idea of a base to an exponent is equal to the value. Being able to work between those two entities is very, very important. Knowing that if two values are equal, if a is equal to b, tells us that ln of a is equal to ln of b, or log base anything of a is equal to log base anything of b. So those are key properties to continue to remember as you go through the problems. I'm going to take a look at the first worksheet. As you look through the problems, if we look at number 4, problem number 4, we have log base 9 of 18 is equal to x. Now I know there's a couple worksheets there for you, I get that, but I'm working on the first one there where number 4 is log base 9 of 18 is equal to x. Now and once again, this would be a type of an ACT problem because one of the answers that they will give you is x is equal to 2. Just because people will go 9 times 2 is equal to 18, and that's my answer because they don't quite understand logarithms and remember back to logarithms. What we have is we have this form right here, and we want to transfer it into a exponential form because none of us have on our calculator a log base 9. We have on our calculator log base 10 and log base e. Log base 10 and e we can do with our buttons on our calculator, but we don't have a log base 9. So if we rewrite this as an exponential form, if we rewrite this exponentially, I have log base 9 of 18 is equal to x. Vivi, did you make it in yet? Mickey, did you make it in yet? Okie dokie. How can I write this exponentially? I have it in a logarithmic form. How can I write that exponentially? Abby, how can we write that exponentially?
9 to the x power equals 18.
9 to the x power is equal to 18. And once again, though, I mean, a common answer to this would be x equals 2. That would be an answer on an ACT question. But we don't have, that is not going to be the correct answer. But what we do have is we have the problem here of this variable is in our exponent. And the most practical use for logarithms is to be able to use the property that if I take the logs of something or natural log of something, I can bring a variable out of the exponent. And that's why we use logarithms. So using the next property, if a is equal to b, well, I have 9x is equal to 8, 9 to the x is equal to 18, then their logarithms will be equal. So we can take the ln or log base 10, it does not matter, of both sides. So we have ln of 9 to the x is equal to ln of 18. Because that variable of x, what can we do with that variable of x? Thaddeus, what can we do with this variable of x? With the logarithm?
You can move it to the front.
We can move it out front. So we have x times the ln of 9 is equal to ln of 18. Now to solve this problem, we want to solve for x. What are we going to do to both sides, Riley, to solve for x?
Divide by ln of 9.
ln of 9, ln of 9. So these cancel. So we have x is equal to ln of 18 divided by ln of 9. So in our calculator, we can go ln 18, close my parenthesis, divided by ln of 9, close my parenthesis. And once again, go to 3 decimal places here with your answer. So we have 1.315. Now, how you can check this is in your calculator. If you go 9, hit your caret button to the 1.315 power. Okay, if I could go 9 caret 1.315 power and hit enter, I get something close to 18. It's not going to be exact because I'm rounding it to 3 decimal places. But you should take it to 3 decimal places. If we go down to problem number 8. Let's look at 6 first. 6 looks like it has some fun to it. We have log base 2 of 12 is equal to x minus 4. Once again, let's rewrite this exponentially. No, what would this look like exponentially? 2 to the x minus 4 power is equal to 12. That is correct. So once again, we can go through the same process. Go ahead and take your ln of both sides. But what comes out front is the entire exponent x minus 4. Now we could do one of 2 things. We could distribute this through if we wanted to, the ln of 2. But what I would tend to do is I would divide both sides by the ln of 12. Or I'm sorry, ln of 2. So those would cancel. So we're left with x minus 4 is equal to this ln of 12 divided by ln of 2. And then I have to get rid of the subtraction by 4. So Preston, what are we going to have to do to both sides to get rid of that subtraction by 4?
Do you add the 4?
Add 4?
Yeah.
So we add 4. So we have ln of 12 divided by ln of 2. That would cancel these out. And then whatever that answer is, we can add 4 to it. When you divide them, you get 3.585, and then we can add 4 to it. 7.585. Let's go down to problem number 8 now. We have log base 7 of x plus 4 minus log base 7 of 5 is equal to 2. Now what we need to do on the left-hand side, before we start doing with anything else, we need to deal with this left-hand side. We need to look to combine these 2 logs into one single logarithm. And we have subtraction here. So when I have subtraction of the 2 logarithms, how can I combine this into one log? Log base 7 of what? Kirsten, how can I combine this into one log?
You do x plus 4 divided by 5.
That's correct. Since we have division, we have x plus 4 on top, and we divide that by 5. And that's equal to the value of 2. Okay, now once again in an exponential or in a logarithmic form, this is difficult to solve. But we can solve this by writing this into an exponential form. So our next step would be write this exponentially. So if you have not done it, please do it. What would this look like exponentially? I have log base 7 of x plus 4 over 5 is equal to 2. Isaac, how can we rewrite this?
Wouldn't it be like 2 and then x plus 4 is the exponent?
Now, what's our base? What's our exponent? What's our value? Once again, you're looking at this right here. Here's my base, here's my exponent, here's my value. Here's my base, here's my exponent, here's my value.
Yeah.
So if I look at it that way, what's my base, what's my exponent, what's my value?
Your base is 7, your exponent's x plus 4, and your value is 2.
No,
is your value x plus 4?
Your value is x plus 4. My exponent's going to be what?
2.
2. This is my base, this is my exponent, and that's going to equal my value, x plus 4 over 5. Okay, so it goes back to our fundamental basic idea of how I convert logs to exponential form or exponential form to logarithmic form. Because in a logarithmic form, it gets confusing. In an exponential form, we now have an equation that we can solve. So we have 7 squared, which is a value of hopefully 49, is equal to x plus 5 over, or x plus 4 over a value of 5. We need to solve for x. We have division by 4. What are we going to do both sides to get rid of the division by 4? Olivia, what are we going to have to do?
Multiply by 4.
Multiply by, not by 4, I'm sorry, this is divide by 5. Multiply by 5 by 5. So we have 49 times 5, let's see, 250, 245 is equal to x plus 4. And then we can subtract 4 and subtract 4. So x would equal 241. Is there any other problems from the front of that worksheet that you want me to go through? Just from the front. I'm not going to go to the back yet, just the front. All right, let's go to the back then. Take a look at number 11. We have the ln, well, first off, ln of x squared y cubed over z. We want to calculate this. And what I'm giving you is the ln of x is equal to 5. The ln of y is equal to 7. And the ln of z is equal to the value of 2. So this is the test in regards to testing this is the testing of your ability to apply our properties of logarithms. I need to first write this. I need to be able to separate these 3 entities So I have things that just involve in ln of x, ln of y, and ln of z, because these are the three things that I know. Ln of x is 5, ln of y is 7, ln of z is 2. So I need to use my properties to be able to split this apart. Once again, if things are being multiplied, I'm going to add individual logs. When I had the ln of x times y, this is ln of x plus the ln of y. When we have ln of x divided by y, this is ln of x minus the ln of y. So when I'm dealing with division, I could deal with subtraction there. When I'm dealing with multiplication, I can deal with addition. Well, on top, I'm dealing with multiplication, and then I'm dividing by the value of z. So looking at, well, what if I just had ln of x squared times y cubed? If I have ln of x squared times y cubed, I can write them in their separate logarithms. So we have ln of, what do we have there, Brooke? What would that be?
You'd have ln of x squared plus ln of y cubed.
That is correct. And then we have division by z in this whole quantity. So to finish this off, we would have to do what with this with this z, Brooke?
Then you subtract the ln of z.
That is correct. Okay, our next thing is to get rid of these exponents here, the 2 and the 3. Jordan, what can we do with these exponents, the 2 and the 3? What do we do with them?
Bring them to the front.
Bring them to the front. So these come out front. So we have 2 times the ln of x plus 3 times the ln of y minus the ln of z. Now the ln of x is just equal to 5. So we have 2 times the value of 5 plus 3 times the ln of y is given to us as a value of 7 minus the ln of z, which is a value of 2. So you can quickly collect this straight through the calculator. You can use your orders of operations. The mathematics is not difficult here. We have a value of 10, multiply first, plus 21 minus 2. So we have 31 minus 2, or a value of 29. If we look at problem number 12, we have the ln of the square root of x times y. Well, when I'm dealing with the square root, what can we do with an exponent? What's your exponent for the square roots? You have a square root. What is our exponent for that? Angelique?
1/2.
1/2. So we have ln of x times y to the 1/2 power. Okay, L, once again, what can we do with this exponent?
You move it in the front.
Move it to front. So we have 1/2 times the ln of x times y. Marissa, when we are multiplying, what do we have to do with separate logarithms? ln of x times the ln of y, what would that equal?
ln of xy.
No, yeah, it equals the ln of xy, but how can we separate these into their own separate logarithms?
Oh, by adding them.
Adding them. So we have ln of x plus the ln of y. Now what you have to make sure of is this 1/2 goes to both of these. So you have to do what's inside the parentheses first. So we have 1/2 times ln of x, which is, once again, a value of 5, plus the ln of y, which is a value of 7. So we have 12 divided by 2, which is a value of 6. Then problem 13, the little nuance to problem number 13. Okay, same property is going to be ln of x plus the ln of e cubed. The exponent of 3 can be moved out front. So we're at ln of x plus a 3 times the ln of e. ln of x plus 3 times the ln of e. Well, the ln of x, once again, is a value of 5. But I don't give you the ln of e. Don't give you the ln of e. Well, what the ln of e is once again the log base e of e. When you're talking about a logarithm, a natural log, when you're talking about a natural log, that is a log base e. So we have the log base e of e. Well, if I take the log base e of e, Brandon, what do you come down to? The base and the value is the same. What do we come up with? You remember?
Um,
When these values are the same, log base e of e.
I don't remember.
Anybody remember? When the values base log base 10 of 10, log base e of e, log base 7 of 7, log base b of b.
Isn't it 1?
It's a value of 1. Log base b of b is equal to a value of 1. So when you have log base 10 of 10, you get 1, or the ln of e, this will equal a value of 1. So we're left to 5 plus 3, which is a value of 8. Any other questions from the backside? Tried to hit some high spots. Some things are a little bit different.
Can you do number 14?
Number 14, we have ln of cube root of x and y divided by y squared. Number 14. Ln of cube root of x divided by y squared. Well, once again, when we have division, what operation do we have to utilize to be able to separate into their own separate logarithms? Okay, go ahead and rewrite. We have division. Don't try to do too many things at one time. When we have division of things, we can separate them into their own logarithms by subtraction. Now, the little difference one here is how do I deal with the ln, or I'm sorry, the cube root of x? Well, when I have the square root of x, the square root of x, this is x to the 1/2 power. When we have the cube root of x, the cube root of x, what exponent could we take the cube root to? The square root is 1/2. The cube root would be, what would we have with the other one? Mickey, did you ever make it in?
Yes, I'm so sorry. 1/3.
And 1/3. It's okay. You need a little rest there. You're binging on Bachelor or Bachelorette. That's fine. You need your rest. So we have 1/3. Just glad to see you can make it today, and you didn't get stuck in a snowdrift somewhere. You're on the way to school or get into an accident on the way to school this morning. You know, it's a little slippery out there this morning. Both of our exponents. Vivi, did you ever make it in?
Yeah.
Whoa, all right, we made it all in today. Another binger on Bachelor. What do we do with both of these exponents? What can we do with the exponents?
Do you multiply them?
What do you mean by multiply them? What do we do with the exponents when we have a logarithm? Where can we move them to?
Oh, before.
Before, so then it would turn into multiplication. So we have 1/3 ln of x minus 2 ln of y. Our ln of x, once again, our ln of x is a value of 5. So we have 1/3 times 5 minus 2 times the ln of y, which is a value of 7, I think. Yeah. The value of 7. So we have 5/3 minus 14. This is 1 2/3. So this was, if I do this, would give me negative 12 1/3 as a solution. Or negative 37/3 would be fine too. Fourteen can be written as 42/3. So we have negative 37/3. I would accept either or. Other ones from the worksheet. All right, let's move to the second worksheet. We take a look at number 8. We have the log of x plus the log of x plus the log of x is equal to 6. Now there's a bunch of ways to skin the proverbial cat here. The first way I look at this, I have log of x plus log of x plus log of x. I could write that as a log of x times x times x is equal to 6, or x cubed is equal to 6. Or I can write this as, let's see, this is 1 log plus a second log plus a third log. 3 log of x is equal to 6. And this would be the same thing up here. The log of x cubed, the exponent can run out front to be 3 log of x. I have 3 times the log of x. I can divide both sides by 3. So we have log of x is equal to 2. And then we can write this into an exponential form. Well, we take a look at the exponential form. I have a base, I have an exponent, I have a value, but I have no number there. Well, if we have no number there, what is it understood to be? Angelique, what's it understood to be if I have no number there?
Log of 10.
Log base 10. So now I have a base, I have an exponent. So I have 10 to the 2th power is equal to my value of x, which is the value of 100. I know, you're sitting here saying, he just makes it look so easy in class. You know, the easiness of just going back to your basic fundamentals of, okay, take it out of a logarithmic form by using the definitions, and then using your exponential form and your ideas is the main thing. If we take a look at problem number 6, we have the log base 2 of 1 over 128, and we want to know what this is equal to. Well, what I said when we're trying to find these logarithms, what I would suggest you do is just write an x in there. Now let's take the log base 2 of 128 is equal to x, rewrite that by using the definition into an exponential form. Brenna, what would this be exponentially?
2 to the x power equals 1 over 128.
That's correct. 2 to the x equals 1 over 128. Now, you can do a couple things here. You can see if it can be written, 128 can be written exponentially, which is what we did before, or you can take the ln of both sides. 2 things are equal, then their ln's will be equal, or the logs, it doesn't matter. Once again, I'm going to use ln just because it's easier for me to write. The variable x, once again, gets moved out front. And we can take and divide both sides by your ln of 2. Make sure you quantify this ln of 1 over 128. So we have ln of 1 divided by 128, and the quantity divided by your ln of 2. I always make the habit of just ending your quantities out, and we get a value of -7. You could also rewrite 128 as 2 to the 7th power. So we have 2 to the x is equal to 1 over 2 to the 7th, which is 2 to the -7th power, and apply the properties we did in exponential equations. Number 7 is sort of a different one too. We have log base 16 of 1/4 is equal to x. So we have 16 to the x power is equal to 1/4. And you could do the same thing to both sides. You can take the ln of both sides and solve. Go ahead and do that if you haven't done already. Olivia, what do you get x to equal? Olivia? L, what do you get x to equal?
I go with -1/2.
-1/2. Now let's take a look at a different way of looking at this. When we have 16 to the x is equal to 1/4, 16, now if I take a look, I can write 16 as 4 squared to the x power. And this is 4 to the 1, this would be 4 to the negative first power. 1/4 would be 4 to the negative first power. So we have 2x is equal to -1. Divided by 2, x would equal your -1/2. So either way, you can solve the problem. And you wouldn't have to go through the logarithms to do that. Is there any others from the front side here of the second worksheet you'd like me to go through? Okay, we go to the back. Take a look at 11 on the back. We have log base 4 of x minus 5 plus a log base 4 of x is equal to log base 4 of 6. This one's a little different looking. But on the front side or on the left-hand side, we have two logs that are being added together. Test, what can we do to combine this into one logarithm on the left-hand side?
Multiply them.
Multiply them. So we have x times x minus 5 is equal to log base 4 of 6. Well, before, what we did at this point is we looked at trying to take it out of the logarithmic form and put it into exponential form. But in this case, both sides are logarithms. So how do I deal with this? Well, if the log base 4 of x minus 5 is equal to log base 4 of 6, what can I write in my next statement? If I have this log of this is equal to the log base 4 of this, what has to be true about the x minus 5 and the value of 6? Brooke, what has to be true about the x minus 5 and then the 6?
They have to be equal to each other.
They have to be equal to each other. So we have x times x minus 5 is equal to 6. Once again, if two things are equal, then their logarithms are equal. Well, if I have a like basis with my logarithms, and I'm taking the log of both sides and they're equal, then the two values inside have to be equal also. So now we have an equation we can solve. X squared minus 5x, subtracting your 6 over, subtracting your 6. We have it equal to 0. We have to watch this type of problem because my signs, since this is a -6, have to be different. I cannot have the same sign, even though this is one of those tricky ones where, well, if I take 2 and 3 and add them together, I get the value of 5, and that's what I need to do to get that middle term. I need to add them together. Problem we have is -2 times -3 is not -6, and +2 times +3 is not -6. So the signs have to be different. So we need to have a plus and a minus here, and then we're going to get a -6 and a +1. Now if I check my middle multiplication, I have -6x, +1x, I get my -5. So we have x is equal to -1 and 6, but once again we have to watch to make sure that we don't make any of our logs negative. Well, the -1 would get us negative logarithms up here, so my only solution that would work would be the value of 6. Do not worry about the bottom one down there if you have a bottom one there. Don't worry about that. Any other questions you have on any of the other problems? The hope is as we go through this, as you go through these, we continually utilize the same properties over and over again. So the process that we start running into is a continual, it's the same thing time and time again. All right, the worksheet, the next one in line is just additional practice with respect to logarithms. I'm going to take a look at problem number 1 because it's a little bit different. We have the log base 2 of the log base 2 of 256, and we want to find this value. Log base 2 is the log base 2 of 256. Well, let's work ourselves inside out here. Let's start with this. Let's find out what this value is here. Let's figure out what that value is. Well, what we have is we have log base 2 of 256 is equal to x. Go ahead and write that exponentially. Preston, what would that be exponentially?
Would it be, would the 256 be in front? Would it be 256 to the x?
Now, what's my base? What's my exponent? What's my value? We're taking out of a logarithmic form and writing it into an exponential form. What's my base? What's my exponent? What's my value?
Would it be 2 exponent x equals 2x?
So we have 2 to the x is equal to 256. So go ahead and take the natural log or log of both sides, divide by ln of 2 if you want. Riley, what did it come down to?
X equals 8.
X equals a value of 8. So this value here is a value of 8. So what this will transform into is the log base 2 of this value of 8. So we can solve for x one more time. We can write from exponent, here's my base, here's my exponent, here's my value. So we have 2 to the x is equal to the value of 8. And this one, hopefully, we can solve a little bit easier to be a value of 3. 2 to the third is a value of 8. The other types of problems on here are very similar to what we have. When I just ask you to write it in exponential form, that's all I want you to do. What does it look like exponentially? Or what would it look like in the logarithmic form? Okay? Or combine the two together into just one logarithm or expand it out. All you're doing is you're applying your properties. All right, I've used most of my time here. I think you have to about 9:50. Yeah, you have another 20 minutes here. Okay, you can work on these, continue to work on the worksheet. Tomorrow we will meet from 8:40. We will go from 8:40 to 9:10. Now, I don't know if I'll utilize that entire time. We'll go through a couple problems here if we need to. But tomorrow will be also a review day. And on Tuesday, we'll have the chapter 4 test. So it's over the entire chapter. And that will be on Tuesday of next week. So Friday will be a review day. We'll meet at our normal regular time, 8:40 to 9:10. And that's a half hour. I should get through what I need to get through with that. And then Tuesday next week, we'll have the chapter test. Sorry, chapter test the day before break. It would have been on Monday, but we don't have school. Or you don't have school or this class on Monday. So sorry about that. Just sort of happened. Questions you have? Once again, solutions are posted to the worksheet, so you can check your answers with the worksheet. Other than that, I have nothing else for you today. Please do continue to work through these. Don't wait till Sunday to start trying to figure out logarithms. Continue to get your practice with respect to logarithms. Other than that, I have nothing else for you. Outside, I miss you guys. I wish you were here in class. Makes it a little bit easier, but this will work. That's fine. We'll make this work. But nothing else for you. If you want to stick around and ask a question, that's fine. Other than that, you guys are dismissed. You're out of here. Enjoy the rest of your day. Adios. Be safe.